Good morning, dear students. Good morning, everyone. Good morning, Nagireddy. Pratish, good morning. Good morning. Vaibhav, good morning. Good morning. Shall we start the class? I hope all are doing good. I hope you have got good results in your 10th board exams. Hopefully, you will be getting very good score and very good marks in your future. I mean, like +1 and +2 courses too. And especially, hopefully, you will be getting very good marks and good ranks in your NEET examination. Okay? Good. Some students are giving their marks also. Very good marks. Very good. Got 548. Good. Okay, nice to see your marks. I hope many of you have got, most of you have got very, very good marks. Okay, so continue to work with the same zeal. Okay, if you work hard, definitely you will be succeeded. Now, if you are preparing for your NEET examinations, along with your hard work nature, hard working abilities, you need to develop some important soft skills. I mean to say, smart work. You need to develop some set of smart work. Smart work in the sense like you need to like develop skills such as reading skills. Okay, you need to develop problem solving skills, analytical skills, time management. Okay, so the all kind of skills should be required for attempting NEET exam in a proper manner. So once after coming here into the offline classes, then we'll try to counsel how to attempt the exam, how to study, and how to manage all these important skills. Okay, how to develop these skills. Right. So yesterday I told you that we will be starting organic chemistry in today's session. Okay. As organic chemistry, if I am talking about organic chemistry is the most important part of the chemistry. And in fact, it is the scoring part. Okay. High weightage part of the chemistry. As you know that chemistry we have mainly three subdivisions, right? There are many different branches under chemistry, but mainly we will be studying about three important branches, as you know very well: physical chemistry, inorganic chemistry, and organic chemistry. Okay, so organic chemistry is the most weightage part of our chemistry, and it is very easy to learn organic chemistry. It's provided if you follow certain instructions, right? If I am talking about physical chemistry, it is conceptual and mostly numerical. When it comes to inorganic chemistry, it is mostly I can say memory basis. Of course, there are concepts too, conceptual, and few things we have to remember. So continuous recapitulation is required for inorganic chemistry. When I am talking about the organic chemistry is logical and it is conceptual, and some cases you have to remember few things. So as I can say this point clearly, so if you learn organic chemistry in a proper manner, it saves your time, right? So organic chemistry is mostly like everything will be given in the question. Okay. So example, they'll give us the reactant and they will mention suitable conditions and they'll ask us to predict the product. If you follow certain guidelines and if you follow important topics under first year course, then organic chemistry would be very easy. Right. Students, I don't know about the holidays. Okay. So you can check it with the respective persons. Fine. So once again, very warm welcome for today's session, day 25th of our bridge course. Okay. So in previous classes, we have discussed many fundamental topics, many concepts, and we worked certain illustration examples also. So today we will be starting about the organic chemistry. When you are talking about organic chemistry, it is a vast subject. Okay. Under organic chemistry, I will try to discuss few important synopsis or important topics. Okay. Okay. I hope all are doing good, all are happy and enjoying the life, all are listening properly. Students, as I told you, if you follow the bridge course properly, you don't require any other foundation courses. If you have already taken foundation courses, that is well and good, but the people who have followed properly the foundation, the bridge course which we have given, it is enough to learn first year course and second year course, and especially for NEET examination perspective. As you know very well, in order to learn the concepts under first year and second year, you need some basic foundation. All the requirements related to basic foundations we have delivered already. You have to learn those topics. Some students were absent. I know that some students in a hurry of checking their examination results, they were absent, and please try to go through the video whatever I have given under last class. In last class, I have explained about the examples for prediction of hybridization. I have given method 1 and method 2, and we followed method 1 and method 2, and I told the students to follow any of these methods whichever is convenient. And afterwards, I have given the prediction of hybridization of carbon in a given hydrocarbon. Okay. Now today we will be starting organic chemistry. Let me brief out the introduction part about organic chemistry. Yeah, very good. Ratna Kumari, very nice. 593 is very good marks. In our Sri Chaitanya, our students got 599. Okay, so I think that is the first mark, and many of our students got 590 and above marks. Okay, so I hope you have got the good results. In hopefully, like you know very well, in our plus 1 and plus 2, plus 1 results have awesome, very good results, and even altogether inter results also very good. Okay, along with along with your board examinations, I think you have to really focus on NEET examinations. Along with NEET examinations, we will take care of your board exams also. Okay, we will help in getting very good marks in your board examination, and mainly we will help and we will be here to help you and mentor you and to guide you about your final destination, that is NEET examination. As you know, this is the right platform for getting a very good score in your NEET examination. Many of our students have got many prestigious institutions, and now our students are going to write NEET exam on May 3rd. Okay, we are expecting our students hopefully will be getting very good marks and good ranks. In future, I'll encourage you guys to study properly and to get the best marks. Okay, and I'll encourage you guys, if you are determined to study focusedly, and like if you are determined to study properly, if you have a predestination and if you are having a proper goal, definitely in your process of journey we are here to help you. Okay, so once again I congratulate each and everyone for getting very good marks. Okay, let's start the class. Right, so if you start the organic chemistry, okay, students focus on the class and listen properly. Fine. Right, organic chemistry, as we know that the compounds, if you observe earlier, they have classified the compounds into two categories. One category is organic compounds, the other category is inorganic compounds. Okay, so they thought that they were categorized the compounds which are obtained from living resources, that is from plants or from animals. Let's say the compounds which are obtained or the compounds which are synthesized or which are obtained from living resources are classified under organic compounds. The compounds which are obtained from mineral resources are called as inorganic compounds. Okay, based on which there was a scientist who named as Berzelius. He was hypotheticated and he was proposed a theory which is called as vital force theory. I don't want to go in detail about these theories. Just let me explain one point, right, under classification. According to this vital force theory, he thought that since the organic compounds have obtained from living resources, we can't synthesize the organic compounds in the laboratory. I am repeating this statement once again. He thought like, since these compounds are obtained from living resources, hence we can't prepare organic compounds in the laboratory. Okay. So later on, Hohler is a scientist. He was synthesized. I think you can name the compound also. Hohler synthesized which compound? Urea. From which compound? Inorganic compound. Oh, this is something interesting. Okay. Our grandfather, let's say Berzelius, proposed that it is difficult to synthesize organic compounds in the laboratory since they have obtained from living resources. In order to synthesize them, we might have to incorporate life into them, which would be very difficult. It is his view. He just proposed. Why we can't be able to synthesize organic compounds in the laboratory? He thought like, since these compounds are obtained from living resources, if someone has to synthesize these compounds in the laboratory, something might be incorporated which is responsible for life. We can't incorporate life into the compounds. Okay? Then later on, Hohler has proved the vital force theory as the wrong theory. He was surprised the whole world by synthesizing urea, which is organic compound. Urea is organic compound. He has synthesized urea from inorganic compound. Okay? It was a revolutionary change. Then later on, many scientists were trying to synthesize organic compounds in the laboratory. Okay, then Berthelot, he has synthesized methane, and Coles synthesized acetic acid. Like many compounds were synthesized in the laboratory. If you observe carefully, nowadays there were millions of organic compounds. Okay, they were synthesized in the laboratory. Then later on, they were slightly modified the definition for organic compounds. If you observe the organic compounds, most of the organic compounds contains carbon as the chief element. Then later on, they have modified the definition into the carbon compounds. Okay, carbon compounds means hydrocarbons. Okay, the compounds which contains carbon and hydrogen are called as hydrocarbons. So therefore, organic compounds were the compounds of carbon. It means hydrocarbons and their derivatives. It means the compounds which containing functional groups also. Okay, I am trying to summarize the points which I explained earlier. Berzelius thought that organic compounds cannot be synthesized in the laboratory based on his theory, which is called as vital force theory. He was trying to justify for his theory. He thought that organic compounds cannot be synthesized in the laboratory because if someone is trying to synthesize the organic compounds in the laboratory, they might have to incorporate the life factor. Okay? And after few years, Holler surprised the whole world by synthesizing urea, which is an organic compound, but he has synthesized the organic compound from inorganic compound in the laboratory. Then later on, many scientists synthesized many organic compounds in the laboratory. And then afterwards, they modified the definition into the compounds of carbon. Carbon and its compounds can be considered as organic compounds. Why we are referring carbon? Because in organic compounds, the chief constituent is carbon. Okay. Then if you observe carefully the hydrocarbons are organic compounds only, and there are many compounds along with the alkyl part, they were be attached with the functional groups. Therefore, organic compounds can be defined in this way. The compounds of carbon, nothing but hydrocarbons and their derivatives. Right? I hope this point is clear. Okay. Then later on, we have many different classifications of organic compounds, open chain compounds and cyclic compounds. All the details we will be studying in upcoming classes. If possible, by tomorrow, we will try to explain the classification of organic compounds. Otherwise, in offline classes, you will definitely study about classification of organic compounds. Okay? Fine. Okay? Now, let's talk about the carbon. What is the unique nature of carbon? As we know that carbon is tetravalent. I think you have studied in your lower sections. And one more unique property of carbon is catenation tendency. Why carbon has so speciality in the whole periodic table? Why carbon is able to be involved in many compounds? What is the speciality in carbon? If you think about the specialities of carbon, carbon is so special in the periodic table. Carbon is able to form tetravalent. It means carbon is able to form 4 bonds. Tetravalency, valency of carbon is 4. Hence, carbon prefer to form majorly all the times 4 bonds. Okay. Now, when it comes to the catenation, what do you mean by catenation? Self-linkage of atoms. So, carbon has unique ability to link with itself. So, carbon atoms can join with another carbon atom, like this. This kind of property of self-linkage of atoms is called as catenation tendency. Carbon has maximum catenation tendency. So carbon can be able to join with another carbon, like this carbon is able to form like linear chain compounds and even cyclic compounds also. Right? Because of its catenation tendency, carbon is able to form open chain compounds as well as cyclic compounds. Okay, these two characteristics have made the carbon so special in the periodic table. Right? If you observe the compounds of carbon in the compounds of carbon, that is organic compounds, I can say, there are many compounds of carbon. Okay, so what made the carbon so special? There are two unique properties. One is tetravalency of carbon. The second one is catenation tendency of carbon. Catenation tendency means self-linkage of atoms of carbon. Carbon has the unique ability of link among themselves. Okay, because of this linkage, carbon is able to form chains, open chain compounds as well as cyclic compounds. Right? Next point. So moving ahead, my dear students, I wanted to say this point. Okay, if you wanted to learn the organic chemistry in a proper manner, if you wanted to master the organic chemistry, the best technique is to be familiar in writing the structures and names of the compounds. Okay, since in organic chemistry majorly we will study about reactions, preparation of a particular compound, and the properties of certain functional groups we will study. Okay, so the people who are very familiar in writing the structures and writing the names of the compounds will be definitely learn the organic chemistry in a easier way. Okay, in the process of learning the structures and names of the compounds, I'll try to give some important inputs. So very important inputs. Today we will be studying about the degrees. Okay, degree means not your I am going to talk about degrees of carbon. We have to talk about degree of carbon, and we have to talk about degree of hydrogen. We need to talk about degree of halogen, and we will be talking about degree of nitrogen, and we will be talking about degree of oxygen also. Sir, do they possess any degrees? Okay, so as we are discussing about the elements, even these elements also possess certain degrees. Okay, so we will be talking about degrees of the elements. So what kind of elements have been included under organic chemistry? As you know that organic compounds contains carbon. Immediately after the carbon we will be writing hydrogen. Along with carbon and hydrogen we will find some heteroatoms also. What kind of heteroatoms have been observed under organic compounds? We may be coming across with oxygen, and even we will find nitrogen, we will find halogen, we may find sometimes sulfur, we may find sometimes even phosphorus also. Okay, so these can be called as heteroatoms. So along with carbon and hydrogen, whatever elements have been included under organic compounds, those elements can be considered as heteroatoms. Okay, we need to study about the degrees of carbon first, then followed by hydrogen and the other elements. Okay, now first I'll start with the degree of carbon. Let's talk about degree of carbon. Students, learn properly and follow the points properly. Okay, degree of carbon. Okay, we have started writing degree of carbon. Okay, so listen properly, students. Listen properly and follow these points properly. This is most important step in learning organic chemistry. In organic chemistry, you need to know about the nature of carbon, nature of hydrogen, nature of halogen, nature of oxygen, nature of the other stuff which have been involved in the organic compound, right? Okay, nice. So degree of carbon. Carbon has mainly 4 important degrees. 1 degree carbon, 2 degree carbon, 3 degree carbon and 4 degree carbon. Okay, this 1 degree carbon is also named as primary carbon. Primary carbon. Okay, and this is secondary carbon. 2 degree carbon is considered as secondary carbon and 3 degree carbon is tertiary carbon, and this is quaternary. Okay, which carbon is considered as 1 degree carbon? Primary carbon is the one. Okay, the carbon which is attached directly with only one carbon, which is directly in contact with, which is directly in contact or attached, directly attached to only one carbon. I'll write, don't worry, let me finish this first. What is the secondary carbon? What is secondary carbon? The carbon which is directly attached to, the carbon which is directly attached to two carbons. Next, what is tertiary carbon? The carbon which is directly attached to three carbons. That means that particular carbon should be in contact with three carbons. Now the carbon, quaternary carbon is the one which is directly in contact with four carbons. Okay? Have you got this point? Right, if I can give the example, you will be able to identify. Let me write in a brief way just to represent. Consider over here, considering primary carbon, let me write here. Okay, I am trying to write over here example. Look at carefully. CH3. Dear students, just for your understanding, I am trying to write like this. Hydrogens I am not representing at present. Then hydrogens I will try to represent afterwards. Okay, just look at carefully. Just look at carefully. Now try to point out any one of the carbon. Let me just take the reference as this carbon. Now tell me student, this carbon is considered as primary carbon or secondary carbon or tertiary carbon? Tell me students, the carbon which I have circled over here is considered as primary or secondary or tertiary? Tell me students, primary or secondary or tertiary? Okay, now this carbon is directly in contact with how many carbons? It is directly in contact with only one carbon. Hence this is a primary carbon. Now just try to look at this second carbon. This carbon is directly in contact with how many carbons? Two carbons. Hence this carbon is considered as secondary carbon. Now moving forward. Now this particular carbon is directly in contact with how many carbons? 1, 2 and 3. Therefore this carbon is considered as tertiary carbon. Now if you just identify this carbon, it is directly in contact with totally 4 carbons. Hence this carbon is quaternary carbon. Next, if you consider this carbon is directly in contact with 3 carbons, hence it is tertiary. Now this is secondary and this is primary. In the same way, this carbon is again primary carbon. This is primary carbon. Again this is primary and primary. I hope this point is clear. Now in total how many primary carbons we have in the given example? Just try to count the number of primary carbons. 1, 2, 3, 4 and 5, 6. Am I right? In total 6 primary carbons we have. 1, 2, 3, 4, 5 and 6. Next, how many secondary carbons are present in the given example? How many secondary carbons are present? It is 1 and 2. How many secondary carbons are present? 2. How many tertiary carbons are present? It is again 2. And how many quaternary carbons are present, or 4-degree carbons are present? It is only 1. I hope this is clear. Okay? Have you got this point? Students, have you got this point? Is it clear? Okay? Good. Now moving ahead, I'll give another example. If you wanted to take the screenshot, you can take the screenshot. Otherwise, you can note it later on. Moving ahead. Okay? Now, example number 2. Now, I'll try to write the compound with hydrogens. There is nothing even in this example also. Just to maintain the tetravalency of carbon, I am trying to write the hydrogens also. My dear students, try to find out the total number of primary carbons, secondary carbons and tertiary carbons in this example. Okay? Now, can you count the total number of primary carbons? Again, chocolate. If you want chocolate, you can quickly respond. How many primary carbons are present in this example, and how many secondary carbons, tertiary carbons and quaternary carbons? How many primary carbons are present in this compound? Students, I hope you are counting. I am waiting for your responses. Are you counting? Yeah, responses please. Now, number of primary carbons. Tell me, number of secondary carbons, number of tertiary carbons and quaternary carbons. Okay? Right. Now, trying to count the primary carbons. This can be a primary carbon. This is also primary. Again, primary. 1 degree or primary, both are same. Okay, again this is primary, again this is primary carbon. Right? Now this is a secondary carbon. Again this is a secondary carbon. This is also a secondary carbon. Now try to note the tertiary carbons. This is tertiary carbon. Again this is tertiary carbon. Next, how many quaternary carbons we have in total? How many quaternary carbons we have? My dear students, this is a quaternary carbon, and again this is a quaternary carbon. Are you getting the answers? So in total we have totally how many primary carbons are present? Primary carbons count, tell me students. 1, 2, 3, 4, 5, 6, 7, 8 and 9. Are you getting 9? Next, how many secondary carbons we have? 1 and 2 and 3. Next, how many tertiary carbons we have? Tertiary carbons we have 1, and over here again one more tertiary, and again one more tertiary I have. In total, how many tertiary carbons we have? 3. How many tertiary carbons we have? 3. How many quaternary carbons we have? In total we have 2 quaternary carbons. I hope so you are getting the same answers. Secondary carbons, this is secondary carbon. Again this is secondary carbon and secondary carbon. In total we have 3 secondary carbons and we have 3 tertiary carbons. Please cross check it once. 3 tertiary carbons, 2 quaternary carbons and 9 primary carbons. I hope you are getting the same. 9332. Very good. Pushpa, very good. Next, moving forward. Shall we move forward? Good. Now, we will be moving to study about degree of hydrogen. Okay. After carbon, next most important person in organic compounds is hydrogen. Okay. Now, after knowing the degree of carbon, we need to know about degree of hydrogen also. Hydrogen has degrees. Can you guess how many degrees are there for hydrogen? For carbon, we have 4 degrees: primary, secondary, tertiary, and quaternary. How many degrees can be expected for hydrogen? Anyone? So, for hydrogen, we have in total 3 degrees: primary hydrogen, secondary hydrogen, and tertiary hydrogen. Okay, and can you expect the quaternary hydrogen? Can you expect quaternary hydrogen? After definition, things will be very clear. So, dear students, I am trying to define what is primary hydrogen and what is secondary hydrogen. And this is tertiary. If at all, if you can expect, let me write quaternary, whether it is going to be existing or not, let's cross it. What is primary carbon? Primary carbon is the one, listen carefully, sorry, primary hydrogen, the one who is directly attached to primary carbon. The hydrogens which are attached to primary carbon. Okay, very simple. You have to count the hydrogens which are attached to primary carbon. Now, what is secondary hydrogen? The hydrogens which are attached to secondary carbon. Okay, nice. Now, what is tertiary hydrogen? The hydrogens which are attached to tertiary carbon. Can you guess now whether this exists or not? If quaternary hydrogen has to be existing, it must be connected to quaternary carbon. If you know about quaternary carbon, then you don't talk about quaternary hydrogen. Quaternary carbon means the carbon which is already in contact with how many carbons? 4 carbons. Carbon tetravalency has been satisfied. Can you expect any other bond which is attached to carbon beyond 4 bonds? We don't expect, we never expect. Therefore, there is no quaternary hydrogen. It is always written as 0, or we don't expect quaternary hydrogens. Have you got this point? Is this point clear? Okay. Now, with the example, things will be very fine. Now, I am trying to give the examples. Let's go back to the previous example and we'll try to count. Okay, shall we count? Have you copied this or have you taken this screenshot? I hope you have taken this screenshot. Let's move forward. My dear students, with the same example, I wanted to count the total number of primary hydrogens, total number of secondary hydrogens, total number of tertiary hydrogens. Can anyone tell me the total number of primary hydrogens in this example, in this particular example? Because we know the information about primary carbon, secondary carbon, tertiary carbon, and of course quaternary carbon, then you can easily count the total number of hydrogens which are attached to primary carbon, which are attached to secondary carbon, and which are attached to tertiary carbon. Okay? Right? So try to give the answer. Students, try to give the answer. Okay? So give the proper answer for total number of primary hydrogens, secondary hydrogens, and tertiary hydrogens with this same example, for which we have counted degrees of carbon already. I hope you are counting. Yeah, tell me the answer. Now, my dear students, if you talk about the primary carbon, this is your primary carbon. For this primary carbon, how many hydrogens have attached? 3. Okay. Now, for each primary carbon, there are 3 hydrogens. In total, how many primary carbons we have? 9 primary carbons we have. Each primary carbon has 3 hydrogens. In total, we will be having 27 primary hydrogens. Next, how many secondary carbons we have? We have 3 secondary carbons. And each secondary carbon has how many hydrogens? 2 hydrogens. 3 times that of 2, in total 6 secondary hydrogens we have. Next, when you are talking about tertiary hydrogens, those hydrogens which are connected to tertiary carbon, now in total we have 3 tertiary carbons. Let's look on the tertiary carbon. This tertiary carbon is attached to only 1 hydrogen over here, and here also 1 hydrogen, here also 1 hydrogen. Therefore, total number of tertiary hydrogens is equals to 3. Now, can you expect any quaternary hydrogens? You can close your eyes and just write 0. Just write 0. Just close your eyes. Blindly you can write it as 0. I hope you are able to count the total number of primary hydrogens, secondary hydrogens, tertiary hydrogens for any given example. I hope so. You can even count the total number of primary carbons, secondary carbons, tertiary carbons, and even quaternary carbons also. Right? Okay. Shall we discuss one more example? One more example. Right? So, if you complete this example, we will be moving towards the next example. Next example. Okay? Now, this is very important compound. Next, how many primary carbons we have? How many primary carbons we have? Very simple. How many secondary carbons we have? How many tertiary carbons? How many quaternary carbons? You need to even count the number of primary hydrogens, secondary hydrogens, tertiary hydrogens. Of course, if they ask quaternary hydrogens, there is nothing such as quaternary hydrogen. You can write it as 0. Okay. Now, how many primary carbons we have? Dear students, if you just focus on this carbon is directly in contact with only 1 carbon. Therefore, this is a primary carbon. Again, this is primary, primary, and primary. In total, how many primary carbons we have? 4 primary carbons. Do we have any secondary carbons? There is no secondary carbon, hence it is 0. There is no tertiary carbon, which is 0. And how many quaternary carbons we have? There is only 1 quaternary carbon. Since this middle carbon is directly in contact with 4 carbons, hence the number of quaternary carbons is 1. Now, coming to the information about primary hydrogens. How many primary hydrogens we have in total? 3 plus 3, 6 plus 3, 9 plus 3, 12. Okay, in total we have 12 primary hydrogens. There is no secondary hydrogen, there is no tertiary hydrogen, of course there is no quaternary hydrogen. Okay, I'll give another example. How will you be able to work this question? This is question number 2 and this is question number 3. Okay, my dear students, try to count the total number of primary, secondary, and tertiary. Shall we count for this example? Shall we count for this example? Dear students, as I told, we will represent the organic compounds with lines. This representation is called as bond line representation. Bond line representation. Bond between carbon and carbon is represented with a line. Okay, it means this is the position of carbon. Over here, carbon, carbon and carbon, all these are representing carbon atoms. Okay, this whatever color I have written, this color is nothing but it is representation of carbon. Just for your understanding, I have written. Now try to count the total number of primary carbons, secondary carbons, tertiary carbons and quaternary carbons. Afterwards, we will count the primary hydrogens, secondary hydrogens and tertiary hydrogens also. Okay, bond line representation of organic compound. Bond line representation. This representation is called as bond line representation. Bond line representation. Now, just forget about this point. Now, try to count the number of primary carbons. Try to count the number of primary carbons. Okay. Now, look at my dear students. This carbon is directly in contact with only one carbon. Hence, this is primary. This carbon is directly in contact with two carbons. Secondary. This carbon is tertiary. Now, this carbon will be quaternary. This carbon is in contact with three. That is why it is tertiary carbon. Now, this carbon is again primary. And again primary. All these carbons are primary carbons. Try to count the total number of primary carbons in this example. There is 1, 2, 3, 4, 5 and 6. In total we have 6 primary carbons. Okay. How many secondary carbons are present in this example? There is only one secondary carbon. How many tertiary carbons are present in this example? There is one here and one over here. In total we have 2 tertiary carbons. Total number of quaternary carbons. There is only one quaternary carbon. Can you count the total number of primary hydrogens, secondary hydrogens and tertiary hydrogens for this compound? As you know very well about the carbon, carbon is a tetravalent element. It means carbon prefers to form 4 bonds. Here, this carbon is already engaged with a single bond. The remaining 3 bonds must be with hydrogens. Okay? In the same way, this secondary carbon is already in contact with 2 bonds. The remaining 2 bonds must be with hydrogen. Again, this is primary carbon, primary carbon, primary carbon, primary carbon and primary carbon. If you talk about the tertiary carbon, this tertiary carbon is already involved with 3 bonds. The 4th bond must be with hydrogen. In this way, you can easily count the number of primary hydrogens, secondary hydrogens and tertiary hydrogens along with primary carbon, secondary, tertiary and quaternary carbons. So with this, I'll stop for today's session. That's all for today's class, and try to work on some other examples of counting degrees of carbon and hydrogen. So thank you and have a nice day.